Okay, so we're going to evaluate the definite integral from 0 to pi of secant squared and we have t over 4 within here in this operator times dt. Okay, let's go ahead and make a u sub here. So let's set u equal to t over 4. And if we take the derivative of both sides with respect to t, we should get that du is equal to, now remember this is a constant, we can pull that out, so the derivative of t with respect to t is just 1/4. And then we can multiply both sides by dt, we get dt over here. So we can go ahead and, well, if we want to replace dt, let's isolate dt. So dt, therefore, if we multiply by 4 on both sides, we get 4 times dt. Sorry, 4 times du. dt is equal to 4 times du. Let's go ahead and change our variable now. So remember, our limits change as we change the variable of which we are integrating. So secant squared of, now u is t over 4, so it's going to be secant squared of u times du times 4. So I'm going to put the 4 out here because our 4 can be treated as a constant, and we can pull out any constants out in front of our integration. So we can do this one of two ways. We can find our limits in terms of u by replacing when t is equal to 0 and t is equal to pi, or we can evaluate the integral and then back substitute in for our variable t and then use our original bounds over here. So that's what I'm going to do. I'm going to go ahead and evaluate the integral. I'm just going to leave the bounds kind of like this because this is denoting that we changed our bounds, but when we substitute back, we'll have our bounds in terms of t again. All right, so what is the integral of secant squared? Well, we have 4 here, our constant. So the integral of secant squared, if you remember, tangent, the derivative of tangent is secant squared. So the antiderivative of secant squared is the opposite of doing tangent derivative, right? So this is going to be tangent of u. And we're evaluating this at our u bounds, or bounds in terms of u. And let's go ahead, and like I said I was going to do, I'm going to go ahead and back substitute in u here. So 4 times tangent of, what is our u? Well, we set u to being t over 4. So we'll go ahead and replace that. Now we can put our limits back here. So t is ranging from 0 to pi. All right, so let's go ahead, evaluate this guy right here. So, do I have room? Thanks for letting me scroll down. Okay. So if we evaluate this, we should get 4. I'll leave our 4 out as a constant. Now, when t is pi, we get tangent of pi over 4. Minus, when tangent is 0, we get tangent of 0. Now, remember our trigonometry? What is tangent of pi over 4? Well, if you remember, tangent of pi over 4 is the same thing as saying sine of pi over 4 divided by cosine of pi over 4. Now, sine of pi over 4 is radical 2 over 2. Cosine of pi over 4 is also radical 2 over 2. So this should actually just be 1. We're dividing by the same number. So tangent of pi over 4 is just going to be 1. And then if you remember tangent of 0 is sine of 0 over cosine of 0. So sine of 0 is 0 and cosine of 0 is 1. So 0 over 1 should make that to being 1. And let me go ahead and say this. So tangent of 1 is 1, tangent of 0 is 0. So 1 minus 0 in this bracket right here is going to be 1. So then 4 times 1 is just going to be 4. And this is our answer.